In this video, I'm going to show you how to use Excel to work the correlation and regression problems from this section in our textbook. And I've taken two examples that are located in the textbook. The first one relates to the number of workers absent and the number of defective parts produced on that particular day. The first thing I did was take this information and put it into an Excel spreadsheet, which I've opened up here, and you have access to this spreadsheet in the same location that you found this video. And so I've got the days of the week here, I've got the number of workers absent, and then the number of defective parts produced. And the first thing I want to do is calculate the correlation coefficient. So I went to a cell here and I typed in R, that's the symbol we use for correlation. And then I go to another blank cell and I type in an equal sign. And when I type in an equal sign, the function window opens up here. And we're going to go ahead and we're going to search for the function. And this function is called CERREL. And there it is there, and I'm going to hit OK. And it's going to open up the function window where I need to tell it where the information is located. So for the correlation, the first array I'm going to use is the number of absent workers. So I take my mouse and I highlight that. And then I click in array 2, and I'm going to highlight the number of defective parts and hit OK. And so here's the correlation coefficient, and it's 0.9 if we round off to 3 decimals, 922. Now I also may want to look at a scatter plot. So let's go ahead and highlight the data that we want to graph, and it's going to be these two columns. Go to Insert, over here under Charts, and it's called Scatter, and there's my chart right there. We're going to leave it out there for a minute, and if I'd like to, on the same design view here, we can add some elements, and you could add a title, you can add chart title, you can add axis labels, and so forth. And I'll let you go ahead and do that. But let's go ahead and just take a look at that scatter plot. So what do we notice here? As the number of absent workers increases, the number of defective parts increases, so which agrees with the correlation coefficient that we found. Now I'd also like to do the regression coefficient, or the regression equation, the line of best fit. So again, I'm going to type in, I'm going to put in line of best fit. Now the problem with this in Excel is it doesn't give you the equation. You're going to have to look at the information as you work with the function window. So type in an equal, and let's go ahead, and it's called LINEST, the line estimate. And the first thing you put in are the Y's, the things that you're trying to predict, and here we're trying to predict the number of defective parts, and it's based on the number of defective workers right here. Now if you look right here, the first number that you see is the slope, which is 3.23, and the second number is the y-intercept, which is 8.52. Unfortunately, Excel does not put that all into a single cell, so you'll have to write this down as you work on it. Okay, the other thing I might want to do on my scatter plot, and if I go again to the design aspect and add a chart element, I might want to put that line that we just fitted onto the scatter plot. So I go down to trend line and I go to linear. And now I've got the equation, the fitted line on the scatter plot right there. So that might be helpful for you. Okay, so let's try a second problem. So let's go back over, and the second problem in your textbook is about the amount of time that has passed since a patient was administered some medication, and they want to know how much drug is remaining in the bloodstream. And if we notice in the table here, as the hours go by, the amount of drug remaining is declining. So we're going to see a different picture on this one when we create the scatter plot. So let's go over here, and let's first do the correlation coefficient. And again, remember, I typed in an R, and then we'll go to the equal sign, and we're going to pull up the CORREL, and we're going to put time in as the X variable, and we're going to put the amount of drug in as the Y variable. And there's my correlation. And notice here it's negative, which is what I expected as I looked at this as the data there, negative 0.871. Okay, let's go ahead and create the scatter plot. So again, let's highlight the data we want in the plot, and go to Insert, Scatter, and there's my scatter plot. And I can see as the time goes by, the amount of drug remaining declines. There seems to be one unusual value here, perhaps. And then the last thing I want to do is the line of best fit. So remember, we use the LINEST function, LINEST, and put in the Y's, and then put in the X's. All right, and then here it is. So the slope is negative 18 point, let's round to 1 decimal, negative 18.1, and the y-intercept is 263. And again, Excel is not going to write that in an equation. You're going to have to write that down. And I forgot to mention, you don't need to worry about these two windows when you're doing this. There are other options for the regression fitting, and you don't really need to worry about that. So hopefully this will help you as you're trying to use Excel to work on these problems. One thing I would also mention is, in order to test the correlation and whether it's significant or not, you will need to use the table from the textbook on the correlation coefficient. Remember, it's based on the number of pairs of data points that you have.